Okay, so this screencast is to go over some of the pedigrees that we've been working with to, hopefully walk you guys through how this works. So my step one for solving any pedigree is to first look for any references either in the text or in the key to whether or not the trait is X-linked or if it's colorblindness or hemophilia. So in this case, it's right up front telling you that this is colorblindness, which we already know is an X-linked recessive disease. So it's going to be asking us for the genotypes of persons 1 and 2, and also something about person 3 children. So before we even start with any of that, let's go ahead and write out all of our possible genotypes and phenotypes. So for colorblindness, I know that this is an X-linked disease, so I'm going to go ahead and write out my X's and Y's for the boys and the girls. So this set here. So I know that for colorblindness, I have two options for the boys. I can have either an uppercase C, in which case this is a normal vision boy. I know that I can have a lowercase c, and denote that any way you want to. Just be sure that you keep them straight. So we're going to call this one colorblind. That's what that says, trust me. Okay, so for the girls, I have a lot of different allele types. So I can have the two uppercase C. I can have a mixture of alleles of an uppercase C or a lowercase c. And then I can also have two lowercase c's. So for the girls, this one's going to be completely normal. When it has this mixture of alleles right here, like what we see, that has their special name, remember that's a carrier. And then when they have the two lowercase, for a girl, she's going to now be colorblind because she doesn't have any good alleles to give her that normal color vision. So now that I have all of my genotypes and phenotypes up, what I can do at this point, and what I would advise that you do, is to start labeling kind of everybody on this pedigree that you can. And because they're asking for like 1 and 2 and 3, we're going to focus on this side. So for the boys, in any X-linked recessive disease, they're going to be the easiest ones to figure out because you only have two options. Either they're going to be normal, and if they're normal, unaffected, like this guy right here, this has to be his genotype. He has to have X uppercase C Y. And if he's colorblind, he has to have X lowercase c y. So let's go ahead and first label all the boys. So this boy right here is going to be, this boy right here is going to, so let's do X, Y for everybody. So X, Y. This one's also an X, Y. This one's an X, Y. So this guy's an X, Y. And then let's label the girls. So X, 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 X. And we're going to focus on this part of the pedigree because they're not really asking anything about the other ones. Okay, so now that I have this, let's start adding my alleles. So this boy right here is affected, and to be affected, he has to have the little lowercase. So we're going to, and I'm just going to put a line under it to indicate that that's a lowercase c. Versus this boy right next to him, his brother, who is unaffected, so he has to have that uppercase C. And then for dad, we know because he is unaffected, he also has to have that uppercase C. And for this dad here, we also know that he has to have the uppercase C. Versus individual number 3, who does have the color blindness, this one has to have the lowercase c. There's no other option for him. So now we have to start thinking a little bit more deeply. So once we have our people sort of labeled, let's start setting up a Punnett grid. And let's go ahead and do it for this part of the family here. Okay, so once you have your individuals labeled, you can now draw your Punnett square. So we're going to go ahead and just put that right in here. And I've just put the lowercase disease allele in a different color so that I don't get confused later on. So let's go ahead and make our Punnett square. We're going to focus on this family right here because that's where most of our individuals are. So let's start with mom and dad. So let's put our X and our Y, and we'll put XX for mom. And so dad is unaffected with color blindness, so we know that he has to have an uppercase C. And we have two boys here, so let's go ahead and write them in. So boys have the Y, and they also have an X chromosome. So now this is where it's going to be different. So one of the boys has an uppercase normal allele, and one of the boys has that disease allele from the color blindness. So boys can only get their X chromosomes from mom. So already right here we know that mom has to have one lowercase c and one uppercase C. So now we have her genotype, and she is person number 2. Okay, so for person number 1, again, you already have this because he's the unaffected boy. So he would have X uppercase C, Y, and because he has that uppercase allele, you know that he does not have, so he has normal color vision. And so for mom, individual number 2, she has this mixture of alleles, so she is a carrier. So that's who she's going to be. And then we can also predict this person's genotype. So this is a daughter. So she's going to be XX. So since we know that mom is a carrier, we know that this person has a 50-50 chance of either being 2 uppercase C's or a carrier herself. Sorry, got those mixed up. So let's do that correct order here. So she would get 1 healthy X from dad and 1 carrier allele from mom. So to solve the last part, let's see what they're asking for. So they want, if person 3 has a child with a woman who is a carrier, what will be the son's genotypes and phenotypes? So to answer that one, let's go ahead and erase this stuff here because we don't need it anymore. Erase. Okay, so focusing on person 3. We're going to draw a new Punnett square. And let's go ahead and just go get dad out of the way. XY, XX. And remember that we know that this dad has the lowercase disease allele. So we already know his genotype, but we're just going to put him here. So we're saying if mom is a carrier, so mom would have 1 uppercase C and 1 lowercase c. So let's go ahead and write our Punnett grid out. So XX for girls, XY for boys. And to track our disease alleles, so this first daughter is going to have an X uppercase C from mom and 1 lowercase c from dad. The daughter on the bottom is going to have 2 lowercase c's. And the son on top is going to have 1 uppercase C from mom. He gets his Y chromosome from dad. And the other son will have this lowercase allele from mom, because we have said she's a carrier. So for the son's genotypes and phenotypes, so we're looking over here. So we have 2 genotypes. So one of them is this one here. So we have X uppercase C, X uppercase C, Y, which is the normal allele, and this one has normal. And I'm just going to put normal, N for normal, but you would have to write it out. And this one, because they have the C allele, is colorblind. So I'm just going to put CB for colorblind. So that's how you would approach this kind of problem. And that's it.